Hi friends, welcome back. So in this video we will see another case study on FMT. So this is the series of FMT, as we all know that. So today we have another case study on model performance measure, ML pipeline and hyperparameter tuning. So again we'll be having some question like statement and we'll be doing the solution for them. So first one is, can you correctly identify glass type, right? So this is basically to identify the correct glass type. So we have the context. So this is glass identification data set from UCI. It contains 10 attributes including ID, the response is glass type and all that. Now this is the detail of our content, and this is the data file or the CSV file, which I'll also provide the link of this file in the description. So the first problem is import necessary library and load the data. So we are importing warnings, pandas as PD, and reading the CSV file into DF. And if we check the head of the DF, so you can see that these are the attributes that we have: refractive index, sodium, magnesium, aluminium, silicon, potassium, calcium, chromium and iron, right? All these. Now split the data into dependent and independent variable. Also see how it looks like. So here we can do like this as well, like x we are taking as df.ilog function, and y again we are taking df.ilog function. We can also have by using the drop method, right? Hope you remember that. Now we are printing the x shape and y shape. So here you can see that df.info, if we print that, so this is the shape, right, that we are getting. And the info, if we talk about the info of our data frame, so this is how it looks like. Now convert target variable into numerical. So again we are using the label encoder from sklearn.preprocessing. So le equals to label encoder, we are calling this function, and then we are le.fit transform of y, right? So we are transforming all these building windows, float processed building window, non-float process, containers, heat lamps and all, and then we are getting the arrays for that. Now split the data set into train test and also the validation. So here to get the train test split, we are importing train test split from scikit-learn.model selection. So x train x test, y train y test. So this is train test split, so it will become 30 for our test set and remaining 70 for our train data, right? Now x train x value, y train y value, similarly train test split. So here we are using 25 for test size, and where the 75 will be for our training size. Now building the pipeline. So again we have the step that instantiate the pipeline as first defining standard scalar, and on the scalar data run the PCA and then feed it to the logistic regression or any other algo. So here we are also having this hint, but as we have the solution, so we can see directly in this. So standard scalar, so we are importing this from pre-processing, PCA from decomposition, logistic regression from linear model, and pipeline from pipeline, right? Now here pipe.lr pipeline, again the same thing we have seen in the last video as well, like how it works. So SCL, standard scalar, PCA and dot components tree. So all these parameters that we are passing, and if we print the test accuracy of this pipe lr dot score, right, of the x test and y test. So here we are getting the test accuracy as 0.523, right? Now follow the above step and check if you can tweak the logistic regression parameters above and make use of grid search. So here you can use any algorithm to perform it. So as it is suggested, we are using grid search CV from a model selection, SVC from SVM, pipe underscore SBC. We are making a variable in which we are calling the pipeline function and passing all the required parameter like SCL, standard scalar, PCA, SVCs, right? Now parameter grid, we are having this parameter grid for PCN component, similarly for SVC, then for SBC gamma, and then for SBC kernel. Now grid equals to grid search CV. So pipe SBC parameter grid, equals to parameter grid cv equals to 5. So grid dot fit will get xtrain ytrain, so it will be giving the best cross validation accuracy, best parameter and test set accuracy. So here the best validation accuracy we are getting 0.73, best parameter, so these are our best parameter, and the test accuracy is 0.69. Now grid dot predict x test, so here we are getting the array of all the x test. Now optimize the model parameter can make use of any algorithm, so make use of grid search for hyperparameter. So again we split the data set into train and test set, make use of any algorithm from the list of hyperparameter, then we apply the parameter grid. Then once hyperparameter grid is defined, we import grid search cv, right, and fit x train and y train. See how beautifully the problems and the solution is stated here. So I hope the effort of our team is really making sense, and it is helping you a lot. Then we are doing the find test, find best parameter and mean test score. So here split the data into train test split, again doing the same method, right, importing the train test split and cross validation score. After having the train test split, we are calling the k neighbor classifier, right. So here we will be passing the number of nearest neighbor. So here if we call the k neighbor classifier, so knn clf dot fit, we are fitting our x train y train here, right. Now the number of neighbors, so the k neighbor classifier is algorithm we are using auto, leaf size is 30, metric Minkowski, metric parameter none and jobs none, neighbors 5, p2 and weight is uniform. Now we are calling the accuracy scores from sklearn.matrix. So here if we define the parameter grid, so n neighbors algorithm like auto, bell tree, kd tree, brute force, right. So from sklearn model selection, import a grid search cv. So here gs equals to grid search cvs of knn clf, parameter grid cv equals to 10. So gs dot fit x train y train, so here you can see that all the value we are getting like this. Now gs dot best parameter algorithm auto n neighbors, right, that is 1. gs dot cv result mean test accuracy, so if we get the accuracy, so here this is the cv, right, so cv result of our mean test score. So this was all about this video. Hope this small video helped you to get or to have some clarity about the model performance and their measurement regarding the ml pipeline, and nothing but the hyperparameter tuning. So yeah guys, this was all about this video. Hope you are liking it. If yes, please do like, share and subscribe, because this is the only thing that is very important to us, right. And we that because that motivates us, to keep to give you contents like this, and that will help you. So let's meet in the next video. Till then, have a good time, enjoy.